Good evening, one and all. In today's session, first we will study some memory management related to structures. We will see how to find out the size of the structure and then one or two programs. And then we will start off with union user-defined structure, user-defined data type. So before that, have you all seen the program video of the student database, the second part, which I had recorded and sent you all? Okay, so now the part about the size of the structure. So now the screen is visible, right? Okay. So now how memory is
Yes.
allocated to the structure or the structure members. So now when an object of some structure, that is the structure variable, when a structure variable is created, the memory block that is allocated is continuous, right? For example, I have shown you previously. I'll just show you once again. So I hope you remember this. Whenever we create a structure variable, what we do is we first of all define the variables of the structure, and then when we create the structure variable, for that variable it has the different parts, means the different variables, and those variables or those parts are stored in consecutive memory locations. For example, you'll have the first variable, then after that you have the second variable, then the third variable, and so on. So continuously or consecutively, one after the other, the variables will be stored of the structure whenever we create a structure variable. So now, for example, if we have this structure ABC, okay, the name of the structure is what? ABC. It has the variables A, B, and C. And we have created the variable of the structure at its declaration part only, like this. After the closing bracket, the structure variable name is var, and semicolon. Now, let the size of integer be 4 bytes. Okay, for different system, it may be different if you are using 32-bit, 64-bit OS, and so on. So suppose integer is occupying 4 bytes and character, as usual, occupies 1 byte. Now, we know that the structure for this example has 2 character variables and 1 integer. So A and B both have 1 byte, and C will have is an integer, so it has 4 bytes. So total is 4 plus 1, 6 bytes. So when I try to find out the size of the structure using the sizeof operator, okay, that means I hope you remember the sizeof operator. The sizeof operator is nothing but this one. So when you create the structure, its variable name is var. So to print the size, you have to print within printf, you have to write size of var, right? Or you can write size of struct ABC. So using this syntax, you can find out the total size of your structure. So ideally the output should be 6 bytes, but the interesting part is you will not get 6 bytes. Okay, the size at the output, you will not get 6 bytes. See, I have run this program already and I've attached the screenshot. What I have done in this program is same structure we have here, and now we have the same structure here. And see, the way you can do it is you cannot print size of ABC like this. It is not allowed. But you can print size of struct ABC, because I've told you that the data type is not only struct, it is struct and ABC, that is struct and struct name. Or you can print the size of the variable of the structure, that is size of the variable of the structure. right? So in both the cases, that is case 2 and 3 are allowed, but you cannot print size of ABC. You can print size of struct ABC, or you can print size of variable of that structure, that is S in this case. So both the times, see, it is the same thing. How much char occupies 1 byte? Again, char occupies 1 byte, and integer occupies 4 bytes. So 4 plus 2, 6, but I'm getting the size 8, right? So this is not as desired or not as expected. So this is because the by default one feature is turned on. Okay, by default it is on, and that feature is called as padding. That is called as structure padding. Because of that, this happens, and it is necessary. Okay, structure padding is necessary to some extent, and that we will see now, that why we need this structure padding and how we can disable this padding also. Okay, sometimes we may need it, sometimes we do not need it. So before going on ahead, let me explain one more concept that we need. See, a char variable will occupy 1 byte. We know that. So it will be stored at the locations. Okay, computer memory is linear. That means one after the other computer memories. Okay, like this. See, linearly, you have different locations in your memory. This is one location, second location, third location, fourth location, and so on. You have many locations. Okay, one after the other, you have the locations in your computer memory. And within these locations, you need to store your data of your variables. Within these locations, the memory will be allocated for your variables. Now, character, since it occupies 1 byte, at which locations it will be stored is different compared to integer. See, character occupies 1 byte, so it will be stored at the locations which are found at multiples of 1. I'll tell you what this means. See, multiples of 1 are what? 1, 2, 3, 4, 5, 6, 7, 8. How do you get multiples of 1? 1 into 1, 1 into 2, 1 into 3, 1 into 4, and so on. So all these locations, each location is a multiple of 1, and each location is suitable to store the character. Suppose you want to store the character A, then its ASCII value gets stored, okay? Or simply for our convenience, let me say that character A will get stored. Now where it will get stored? Anywhere at any location. Okay, suppose at location 8 it is getting stored. It will occupy only one location, and each location is of how many bytes? Anyone knows? It is of 1 byte. Each location is of 1 byte. That is nothing but how many bits? Anyone?
8.
Yes, 1 byte is 8. Each location is of 8 bits, or each location is of 1 byte. Character occupies how much? One character occupies 1 byte. So one location is occupied by one character, right? So this character can be stored in any one location. Okay, this character A. Now, this is not the case for integer, because integer will occupy 4 bytes. So how many locations you'll need for integer? 4 locations, because one location means 1 byte. So 4 locations can store 4 bytes. Now, it is not that this integer, just a minute. It is not that this integer will occupy any consecutive 4 locations. Okay, 4 locations means together one bunch, one set, or together one collection of 4. Means either this 4 locations, or these 4 locations, or these 4 locations, or these 4 locations. Starting from 0, the location 0, 1, 2, 3. These are a consecutive group of 4 locations. Similarly, location 4, 5, 6, 7 is a set of 4 locations. Locations 8, 9, 10, 11 is a set of 4 locations, and locations 12, 13, 14, 15 is a set of 4 locations. Only at the multiples of 4. Multiples of 4 means what? After every 4 locations, you can store one integer. Means one integer can be stored here. Then next integer can be stored here. Next integer can be stored here, and so on. But it is never the case that, suppose here you have some characters, means here you have a character A which will occupy 1 byte, suppose location 0. Suppose character B occupies location 1. Then this set of locations 0, 1, 2, 3 cannot be used to store the integer, right? Because 0 and 1 are already occupied by something. So it is not that 2, 3, 4, 5. 2, 3, 4, 5 is also a set of 4 locations, but that will not be occupied, because integer will only occupy after multiples of 4. Means if anything is stored in 0, then integer cannot be stored at 0, 1, 2, 3. It will always be stored starting from 4 onwards up to 7. Another example, suppose something is already present in 9, location 9. Then you cannot use these locations 8, 9, 10, 11. Only from 12 onwards, you have to count 4 locations, that is 12, 13, 14, 15. And all these 4 locations will be occupied by integer, right? So it is not the case that if something is occupied, then immediately next you can start. Suppose location 0 is occupied, then you cannot use 1, 2, 3, 4. It is not valid. Only a consecutive set of 4 which are at multiples of 4. Multiples of 4 means this location 4, 4 is nothing but multiple of 4, 8 is nothing but multiple of 4, 12 is nothing but multiple of 4. So starting from 4, you can store up to 4 locations. Suppose location 10 is occupied, then next multiple of 4 is what? 12. So 12, 13, 14, 15 can be occupied by the integer. Have you got this?
Yes.
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 Does anyone want me to repeat it or have you understood? Should I repeat? Okay, so you have
No.
understood. Yeah. Okay, so this was the case for integer. Only at the multiple of 4. Why multiple of 4? Because it occupies 4 bytes. Okay, so multiple of 4 is 0, that is 0 into 4, means 4 into 0, or 4 into 1, 4 into 2 is 8, 4 into 3 is 12. So only starting from multiple of 4, you can store the integer. Okay, this is how it happens internally in your memory. Similarly, double is occupying 8 bytes. So here, multiples of 8 you have to consider. For example, 8 into 0 is a multiple of 8, that is 0. 8 into 0 is 0. So you can utilize 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7 is a collection of 8 locations, that is 8 bytes. That is, you can store one double. Next double can be stored at which one? Starting from 8. 8 is nothing but 8 into 1, it is a multiple of 8. You can start from storing from 8, 9, 10, 11, 12, 13, 14, 15. These 8 bytes will be occupied by the next double variable. But it is not the case that you can start storing from 4 and you'll occupy 4, 5, 6, 7, 8, 9, 10, 11. No, this is not possible. Double will always get stored starting from the multiple of 8. Means you can start storing from 0, you can store starting from 8, you can store starting from 16, okay, multiples of 8. Similarly, for short variable occupies 2 bytes. So you can store at the multiples of 2. You can store at the locations 0 and 1. You can store at 2 and 3. You can store at 4 and 5, 6 and 7. Suppose 8 is occupied by something. You cannot use 9 and 10. You can use 10 and 9. Multiples of 2, from there you have to start. Is it clear?
Yes.
Okay.
Yes.
So this
Yes.
causes the padding actually. Okay, this is the cause of padding and why, that we are going to see now. So we understood that at which locations, which type of variable can be stored. Okay. And this is same for all your operating systems. Okay. Not only Windows or Linux or Mac, for all the existing operating systems, this is possible. Now, also note that suppose you're using a 32-bit processor. Okay. 32-bit processor. Then at a time, it will not read only 1 byte. Okay. 1 byte means how much? 8 bits. 1 byte means one location. So this data that you store in your variable means the variable is allocated memory in your computer. So the data is stored in the memory. So this memory has to be read in order to access that data, right? If you want to print the data of the variable or the value of the variable, you have to use printf and we have to access that value of that variable. But where is that value stored? In memory. So it is called memory read operation. You need to read the data from the memory. So it is memory read. So reading means how it will read. It will not read only one location at a time. One location means 1 byte. It will not read only 1 byte at a time. No, it will read more than 1 byte at a time. Now, how we know how many bytes it will read? It depends on your OS type. For example, if you have a 32-bit operating system, then it will read at a time 4 bytes. That means 4 bytes is nothing but 32 bits, right? 4 bytes is nothing but 32 bits. See, one location, let me write it below. One location is equal to 1 byte is nothing but 8 bits. So if we want to store 32 bits, how many locations we'll need? Can anyone answer?
Two.
No, not two. If you use two
Four.
locations,
Four.
yes, you can use
Four.
4. Yeah. See, if you say one location is 1 byte, two locations will be 2 bytes, three locations 3 bytes, four locations 4 bytes. Now 4 bytes is nothing but 8 plus 8 plus 8 plus 8, that is 32 bits. So you need 4 locations, that is nothing but 4 bytes, if you want to store 32 bits. And if you are using a 32-bit processor, then at a time 32 bits will be read. Means at a time you are reading 4 locations or 4 bytes. Each time the memory is read, always 4 bytes maximum will be read in one cycle. Okay, in one cycle means first time if you read, you are reading 4 bytes or 4 locations. You are reading the data from 4 locations, 4 consecutive locations. Second time if you go to read, you'll read the data from the next 4 locations. Third time if you want to read from the next 4 locations. Suppose you're not reading consecutively, then randomly, but always 4 locations. Since it is a 32-bit OS, always at a time 32 bits, that is equal to 4 bytes, that is equal to 4 locations. Always 4 locations will be read no matter what the condition for 32-bit processor. Similarly, if you have 64-bit processor, 64 bits means 8 bytes. See, 1 byte is 8 bits. We know that 1 byte is 8 bits. 2 bytes will be 16 bits. 3 bytes will be 24 bits. 4 bytes, 32 bits. Then 5 bytes, 64, um, 8, 16, 6, 8 3s are 24, 8 4s are 32, 8 5s are 40. Okay, 40. Then 8 6 are 48, and so on. You have to go up to 64. 64 bits means 8 bytes. Let me write it down here. 64 bits is equal to 8 bytes. That means 8 bytes means how many memory locations?
8 memory locations.
Very good. 8 memory locations. So 8 memory locations. So at a time you will read 64 bits because it is a 64-bit processor. Means at a time you can access 8 bytes or 8 memory locations. Okay. See, these are the basics of the microprocessor subject also. And if you pay attention now, no, it will become very easy. How many memory read cycles and all that. Okay. In second year you have microprocessor subject. So at a time, if you have a 64-bit processor, that time it will read 8 bytes. Okay. So in your computer also there is a processor, and based on the processor you can have your OS. So each time here 8 bytes will be read if you're using 64-bit processor. Okay. So this is what I've explained, that at which locations you can store which type of data. Integer at the location starting from multiple of 4. Double starting from multiples of 8. Character, since it is 1 byte, multiples of 1 are at each memory location 1 byte. Okay. So now let us discuss something. If you have an integer variable, if you have an integer variable and currently your memory block is empty, so you can start storing, ideally you can start storing from which location? You can start storing from the location 0. So 0 1 2 3 will be occupied by the first integer. Now if you have a character, at which possible location it will be? Can anyone answer? Okay, suppose it is a structure, then the character is stored
8.
consecutively. Sorry.
8.
Yeah, you can store at the location 8, you can store a character. At 12 also you can store, 10 also you can store, that is multiples of 1. But in structure what happens? Consecutively you store. Suppose your structure has an int a variable, then a variable will occupy these first 4 locations. Okay, it will occupy all these 4 locations. A will occupy the bytes of a, means first byte of a will occupy location 0, second byte of a will occupy location 1, third byte of A will occupy location 2, fourth byte of A will occupy location 3. So 4 bytes have been stored. Next, in your structure, if you have a character B, then this character occupies only 1 byte, and consecutively, since it is structure, its members are stored consecutively in memory. So B will be stored at location 4, right? Am I right?
Yes.
Yes.
Yes. Yes. If you have another character C, at which location number it will be stored? Can you tell?
5.
5.
5.
Very good, 5, because it's consecutive. Yes. If you have another character D at location 6. Okay, so the characters can occupy one by one location. So if you have a character, it will occupy 4. If you have another character, you can occupy it at 5. Now, if you want to store another integer, okay, if you want to store another integer, can you use the location 6, 7, 8, 9? Can you use?
We can use only 8 and from 8, no?
Yes, from 8 you can use 4 locations because integer has 4 bytes. So 8, 9, 10, 11 you can use, but you cannot use 6 and 7. So that means these locations, location number 6 and 7, will remain empty because after this character, next is integer, but you cannot use 6, 7, 8, 9. You can use from multiples of 8, multiples of 4. Multiples of 4 are what? 0, 4, 8, 12. So next you can start consecutively, means next best location is 8, right? From there consecutively you can store 4 bytes. So next integer will occupy this much. So we can say that location number 6 and 7 are empty. Okay, location 6 and 7 are empty. And next integer will be stored at 8, 9, 10, 11. Now, if you have a short variable, you can store it at the multiples of 2. 12 is multiple of 2, right? So you can store at 12 and 13, 2 bytes short occupies, so 2 locations. Next, if you have a character, can you occupy it at location number 14? Yes?
Yes.
Yes, you can
Yes.
Yes.
occupy. Yeah. So character will occupy 14. Another character, if you have, you can occupy 15. And so on, it will continue, okay? But in between, if not suitable, that location you have to leave it. That will remain empty. And because of this, the size of your structure is increasing, right? We saw that ideally the size of the structure was 6 bytes, but due to this padding, it went up to 8 bytes. That means just now we saw, right, 2 locations empty, so that was getting added up. Now let us run it same thing for this set of variables for this structure. See, now we have the variables A, B, and C. That is, we have character, character, integer. And the order in which you specify them over here, first is character, then again int. In this order only it will occupy the memory. Okay, so first you'll store A, then you'll store B, then you'll store C. But how? Let's see that. So see here, we have a character A. We can store the character at the location. Just a minute. Yeah. So we can store the character A at the location 0. Okay, because one location, 1 byte, character occupies 1 byte. We can store A over here. Next we have B. We can store it at location 1. Now we have integer. So we cannot occupy 2, 3, 4, 5. Can we start at 2? No, we cannot. It is not a multiple of 4. Can we use 3? No, we cannot use. Can we use 4? Yes, we can start from 4. Can we use 5? Yes, we can use 6, we can use 7. That means we have to leave 2 and 3 empty. Character A has been occupied, B has been occupied. Now this integer has to be stored at 4, 5, 6, 7 only. That means these locations 2 and 3 have to be left empty. That means what happened now? A had 1 byte, so this is 1 byte occupied. B variable is a character, it will occupy 1 byte. Then this byte 2, at location 2, that byte, each location is 1 byte. So this location is nothing but 1 byte. Location number 3 is 1 byte. Then 4 bytes will get stored at 4, 5, 6, 7 for the integer. That means 1 byte, 1 byte, 1 byte, 1 byte. This much is 4. Then again for the integer you have 4. So 4 plus 4 is 8, and that's why we were getting 8 at the output over here. Right? We have got 8 over here. That is because character, character, leave 2 bytes, then integer, 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 integer. Okay, that is how it was. 2 bytes that you had left, that was getting added into this. Have you understood this?
Yes.
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 Okay. So this is how this location which we left empty, right? That is called as the padded location. Okay, that location has been padded. Means nothing but you have left it empty. That is called padding over here. So now, what is the advantage of this padding? Okay, you might be thinking that why not store it consecutively? The reason is in one CPU cycle is nothing but each time that you're doing that process. First time or first cycle, okay, first time or first cycle, what will happen? Four locations will get read in 32-bit system. What will happen? At a time, you can read four locations. Means what? These locations 0, 1, 2, and 3, they will be read at a time. For the first time, these four locations will get read at the first cycle or first time. It is called a cycle or CPU cycle or memory cycle. Memory cycle because you're reading the memory, because you're dealing with the operations of memory. So in the first CPU cycle, the character A and B you can access, right? Because they are present in these four locations, you can access A and B. But suppose you do not store your integer after the multiples, what you are doing, you're storing the integer from the location 2, 3, and you're using 4, 5. If you did it this way without padding, okay, if you had done without padding, then what would have happened? First CPU cycle, you can read the location 0, 1, 2, 3. That means you have read only 2 bytes of the integer, right? You have read byte number 0, 1, 2, 3. Okay, and you're storing the integer in 2, 3, 4, and 5. That means in the first cycle, you have accessed character A properly, B properly, but you have only accessed 2 bytes of your integer. The remaining 2 bytes will be accessed for the second CPU cycle. That means to access this integer C, you need 2 cycles. 2 times you have to read the memory. But suppose you store the C variable, suppose you store the C variable after the multiple. That means at the multiple of 4, if you store, then what will happen? In the first cycle, you will read the first 4 bytes, A and B are read. Okay. But in the next cycle, you will read the integer C. That means another advantage is, suppose you want to read only the variable C. You don't want to read character A and B. You only want to read variable C. Then if you store it consecutively without padding, first cycle, you'll access first 2 bytes. You'll access byte number 1 and 2 of integer, and in the next cycle you'll access byte number 3 and 4 of the integer. But if you want to access only C, you have to use 2 cycles in this architecture. But if you store it at multiples of 4, then what will happen? Only in one cycle these 4 locations will get read. Only in one cycle these 4 locations will get read. That means if you want to read the variable C, you will only need one cycle. But in the previous case, if you had to read variable C, you had to use 2 cycles. In one cycle, first 2 bytes, next cycle, next 2 bytes. But because of the padding, what is happening? You just need one cycle to read that integer. Have you understood the advantage of padding?
Yes, but I have a doubt.
Yes.
Uh, Even if we start integers, if we start saving integer value from 3, 4, 5, 6, then in first CPU cycle it will read only the 3, 4 of integer, right? Sorry, 2, 3 of
Yes,
integer.
yes, yes.
Then what will be, would it show any error in the output window?
No, no,
Like,
no, no.
would it take more time?
No, it will not mean time is not the thing here. Only we will discuss with memory, because what will happen? See, the microprocessor that you use in your computer, means it comes with the computer. Inside the computer, it is inbuilt for you. You have to not attach any microprocessor to use your computer, right? Microprocessors inside your computer. See what happens. This is a part of microprocessor actually. Whenever the memory is accessed, what happens? It is not directly decoded. Whenever you read your memory, you can know that whether you're accessing some data or not. Suppose you access the data, you have accessed only half part of the integer, right? You have accessed only half part of the integer. What will happen? This
Yes.
how much ever you have accessed, that is stored in one queue. Okay, that is the queue data structure, or the queue principle is used. 2 bytes will be stored. In the next cycle, next 2 bytes will be stored. Okay, I have not processed it. I've only read it and I know, okay, I have this much information. I have not processed the information. Uh, Let me show you. Okay, just a minute. Hold on. I have the diagram of a microprocessor, how it works and all. Just have to search it. Okay, just wait for 1 minute.
Okay.
Yeah, actually, we had this subject in second year, so I know it very well. Mm, yes. So now what happens? See here, whenever you read from the memory, okay, this is the memory interface thing that you can see here. Memory interface means whatever will be stored in memory, you can access from this part. Now, whenever you access 2 bytes, okay, means actually you're accessing 4 bytes at a time, that will get stored in this queue. This is called as instruction queue. Okay, so first the bytes will get stored here. 4 bytes will get stored. Next 4 bytes will get stored. Then again 4 bytes will get stored. Again they'll be stored. Okay, means the information in the form of binary, zeros and ones. Okay, because everything works in binary for your computer to understand. So these bytes will be stored, but they are not processed. You have just stored them, means you have collected your information. After you collect your information one by one from this queue, all the data will be processed. So what happens in this queue? You have all the information, and the size of this queue is equal to the memory occupied, the largest memory occupied by an instruction. Suppose an instruction occupies 8 bytes, okay, and that is the maximum that you can have, 8 byte instruction. Then the size of the queue will be 8 bytes. Suppose the maximum size of an instruction is 16 bytes, then the queue will be 16 byte. That means this queue can be used for a 4 byte instruction, 8 byte instruction, 6 byte instruction, and maximum 16 byte instruction. So depending on that, all your instruction, all the data will be stored in this queue, and it is not that half part is missing, half is available, because maximum the instruction has 16 bytes, and all the 16 bytes are available in this queue, and then one by one you will act upon that. Okay, so this is how. It is not that there will be some error or anything. Whatever is gathered will be stored together, and collectively you will act upon that. Is it understood?
Okay, so if in a structure we have a character and int, then the maximum size of character between character and int is int, that is 4 bytes. So that
Yes.
so the maximum size of q would be 4, right?
Yeah, if you have only char and int.
Okay,
But
okay,
here what
understood.
you have, maximum you can have a long double, right? That occupies 10 or 12 bytes. Okay, so that is why,
Okay,
yeah, so that is why if you have a 32-bit microprocessor, it has the maximum size of instruction as 16 byte. Okay, so in 32-bit microprocessors like 80386 SX or DX, there you have an instruction queue of 16 byte. Okay, so this is how the size of the queue is decided. So never it will happen that half information is there, half is not there.
but if there is no benefit of using like if the program if it is able to read half in the queue and it is able to gather, then what is the benefit of say starting it from saving it from 4, 5, 6, 7 memory location?
Because you need lesser number of cycles, right? Means what will happen if you want to read only C variable, you'll need 2 cycles. But by padding, you can use only 1 cycle. Means faster you can access your data, right?
Okay, so it will save time, right?
Yeah, saving time. And as but here memory will not be saved. 2 locations are empty. So it is occupy more memory, means the size of your structure will increase, but it will reduce your time complexity,
Okay,
right?
understood.
Yeah. So now this was the use of padding. So we have seen that the size is now what? You'll occupy 1 byte for char, 1 byte for one for A, one for B, 2 locations are empty, and then 4 locations for C. So total is 1 plus 1 plus 2 plus 4. That is 8 bytes. So output of the program is 8, as we have seen. Now what happens if the order of these members are changed? Now I told you that if you have char and then int, this way only it will be stored. First char, then int. But suppose you have int, then char, then int again. So how does the order matter? So that we will see now. Suppose you again have ABC variables, but now you have char, then you have int, and then you have again char. Means what? You have 1 byte variable, you have 4 byte variable, and you have again 1 byte variable. So here the size will change. It will become 12. It will not remain 8. Now why, we will see. Now suppose again you have the set of 4 locations. Now I'm dealing with 32-bit OS, right? 32-bit architecture. That is why at a time I'm considering a group of 4 locations. If you had 64-bit OS, then at a time 8 locations. So now 4 locations. So char A, it can be stored at this location, at location 0. Just a minute. So all your hardware and software have to work together. Then only you can have the proper programming, right? Software is just what you install, but how it will work, it depends on your hardware. That is what type of microprocessor you are using. So character can be stored at location 0. Considering that the block is empty, you can store at the 0th location. So you'll store A. Now next you have integer B, but I cannot use 1 to 3, right? Because I have to store at multiple of 4. So I will start from location 4, 5, 6, 7. So this whole thing 4, 5, 6, 7 will get occupied by integer. So how many locations are empty? 3 locations. Location 1, 2, and 3 are empty. So till now I have accessed how many locations? 8 locations. That is nothing but 2 bytes. Sorry, not 2 bytes. This is how many? 8 bytes. 8 locations means 8 bytes. I have accessed 8 bytes. Now, yeah, this is empty. Okay, now for to store the variable C, just I need one more location and I can store it over here. But I will read how many? I will read all these 4 at a time, right? I'm reading 4 locations at a time. That means I have read 4 locations, I've got A variable. The next 4 locations I've read, I've got B variable. Then next 4 locations I've read, I've got C variable. But C is located at only one location. Means I don't need this remaining 3 locations, but I have to read them, right? Because at a time I have to read 4 locations compulsorily. That means total is 4 bytes, 4 bytes, and again 4 bytes. That is 4 plus 4 plus 4. Total size will become 12. Now this is what you understand, that how many more times I read, corresponding to that my size will become. Means if I read 3 times, I'm reading 4 bytes, 4 bytes, 4 bytes. That means 12 bytes. If I'm reading 6 times, I'm reading 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. Means I'm reading 6 into 4, that is I'm reading 24 bytes. That means how many more times I read, I have to keep on adding 4 bytes. I read 1 time, I have accessed 4 bytes. I read 2 times, I have accessed 4 plus 4 bytes. If I read 3 times, I've accessed 4 plus 4 plus 4 bytes. So that means how many ever variables are there, each will have, means each is corresponding to 4 bytes. Okay, indirectly you can say this. That means I'm getting 12 as the size. Okay, that is because I'm leaving the locations empty in between if I'm not storing at the multiple of that correspondingly. So have you understood why it has become 12 this time and not 8?
Yes.
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 Yeah, yeah.
And if we
So
have
now what is the,
64-bit operating system, then the size would
yeah,
also increase, right?
yes, at a time you are accessing 8 locations.
Okay.
Yeah, you can apply the same logic that for 64-bit also, no problem, you'll get it. Actually I don't have much time, so I, okay, it's the same thing, you can try it out. If you don't get it, you can ask me. Okay, so 3 words. Word means what? It is not the 16-bit word that I'm talking about, it is the locations that I'm accessing at a time. Okay, so I'm accessing 12 bytes or 12 locations for this particular structure. So what are the effects of this padding now that we will see? Some effect will be an advantage, some effect may be a disadvantage. So it increases the size, obviously, because you're leaving some empty space in between. Okay, it leaves some empty locations, so size is increasing. But the memory occupied by this structure of the variable will also increase because of this. Okay, how many, the size is increasing means what? Size of the structure is increasing because you have to access the variable of the structure. But it will save the CPU cycles, right? We saw that if we want to access the variable C, we can access it only in one cycle if we store it at the multiple of 4. So it reduces the number of times you access your memory. It reduces the number of operations to read your memory. It reduces the number of times you interact with your memory. And that is good, right? Because it will save time. Because your microprocessor is one unit, and to that you have to attach the memory. You have to attach the RAM and ROM. RAM and ROM is not inbuilt with your microprocessor. Okay, if you have your microprocessor over here, okay, microprocessor, you need to interface or attach or connect or join the memory to it. Similarly, you have to attach the input output devices to it. It is not inbuilt with your microprocessor. That is why your mouse is connected to your computer, your keyboard is connected to your computer. Keyboard is nothing but input device, right? So you have to connect everything. It is not that it is inbuilt for your computer. That means you have to interact with your external devices. You have to interact with the memory. And the lesser you interact, faster it will happen, right? So this is the advantage, that it reduces the number of times you communicate with the external device, or reduces the number of CPU cycles, but it will increase the memory. So in which application it is suitable? If you want to save the time of your program execution, that time you can use the padding concept. But suppose you want to decrease the size of your program. That means if you want if your program is a very big program, like hotel management system, everything is computerized, then so much data of each customer and all. So you want to save the memory or the size. That time you have to not use padding. Okay, so you have to disable the feature of padding. This padding feature is by default turned on for each compiler. Okay, it is turned on, it is activated. You have to deactivate it if you don't want to use padding. That means if you don't want to increase the size, if you want to reduce the size, you have to turn off this padding feature, and that is called as packing. Okay, structure packing is nothing but you are turning off the padding. And why you have to turn off padding? If you want to save the memory or if you want to reduce the size. So now this leads to the next concept of packing. Packing is nothing but you're turning off padding. That is the simple thing. Okay, packing means you will save your memory. But if you're turning off padding, what is the disadvantage? This number of cycles will increase. Okay, that becomes a disadvantage if you want to reduce the number of cycles. That means if you are using padding, I'll summarize it right now. If you are using padding, what will happen? Size will increase. But if you are using packing, then size will decrease. Another thing, if you're using padding, the number of cycles will decrease. But since you're not using padding, you're using packing, number of cycles will increase. So if one thing is going down, the other thing is going up. Means if size is increasing, then cycles is decreasing. But if size is decreasing, cycles is increasing. Okay, so both will not increase or decrease at the same time. If one thing increases, the other thing decreases. Okay, in padding, you can increase the size, but in packing, you can decrease the size. In padding, number of cycles reduces, but in packing, number of cycles increases. So it depends on your application. If you want to reduce the size, go for packing. If you want to increase the number of cycles, go for packing. If you want to, means any one parameter, either size of cycles can be minimized or optimized. Have you got this difference? Yes.
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 Okay, now how this packing works, how you can disable the padding. Okay, that is by a preprocessor directive. Now for the same structure, just a minute. Yes, so now this padding can be decreased or removed or turned off by or deactivated by this packing feature. Means you have to enable the packing. And how you will enable the packing? To enable the packing, as I said, you have to use preprocessor directive. So we have seen that the output was 12. Okay, for this case, when we used padding, by padding, the output became 12. But ideally, if you turn off the padding, then the actual size of the structure will get displayed as the size. Actual size of the structure is nothing but character occupies 1 byte, int occupies 4 bytes, and again character occupies 1 byte. So actual size is nothing but 6. And this 6 you will get at the output if you use packing. If you use padding, you will get 12. But if you use packing, you'll get the actual size of the structure. That is the actual size of each variable you have to add it. So we can avoid the um, wastage of memory, right? We have reduced the memory, or we have prevented the wastage of memory by using packing, but we have increased the number of cycles. So to enable this packing, you have to use this preprocessor directive, that is hash pragma pack1. You have to write it as hashtag, that is how you write hash include stdio.h. Similarly, hashtag pragma and then pack, and within the parenthesis 1. 1 means what? It is a boolean value for true, means you're enabling packing, right? It is like a function call. Pack is a function like to which you're passing the parameter 1 to enable the packing. Once you enable packing, you'll get the actual size of your structure. So as I said, this should become 6, right? You'll get the output 6 for this. So pragma is a special purpose directive used to turn on or off certain features. You can turn on packing using this directive. So you'll get the size 6 when you run this program. I've already run the program to save time. Okay, and the same screenshot I've attached over here. So what is this effect of packing now? What are the advantages we will discuss, and why we should use packing, and why and when we have to not use padding. As I've already said, it will reduce the size by disabling the padding. It will display the actual size. So the actual memory occupied by the structure will be reduced, but it will increase the number of cycles. It increases the number of CPU cycles or memory cycles. So as I said, if you want to save your memory, use packing. If you want to save the number of cycles, use padding. Right? Have you understood these two terms in the structure, padding and packing? Yes or no?
Yes. Can
Yes.
you go back to that example which you showed to us?
Yes.
That char int,
Yeah, yeah.
char int, that one.
So as I had said, you have a char, and you have an int. So 1 byte, 1 byte, and 4
So,
byte.
so what I want to say is, without disabling carding, uh, if
Your
we
voice is
declare
breaking.
int
I'm not
at
able to hear you. Just repeat.
if we want to use the benefits of padding without disabling it, so can we declare int first, then char, and then char, like int c, then char a, and then char
Yes,
b,
correct.
and then
Correct. You can
calculate
do.
the size, then it will give us 6
Yes,
without
yes. You will get
disabling
that.
padding.
Yes. But what is the this thing? If you have multiple variables in your structure, you can't keep studying that if I use this one first, how it will be. If I use that one first, how it will be. Suppose you have 10 variables in your structure, then you will not be able to decide, means it will be time consuming to decide which one to put first and next. So that is why this feature, which the compiler will do for you, it will enable to display the actual size of the structure to save the memory, or you can increase the memory by padding. So that is the you can just directly use this feature instead of wasting time in thinking which one to put first, right? What you said is correct, you can do that, but ideally you must do it by this padding and packing feature, right?
Okay.
Yeah.
Yes.
Yes. So let's see one example now. Okay, I've discussed this example on the PPT. Now let us run one example and see. Okay, so here, just a minute. So in this example, as you can see, we have a character, then an integer, then another character, and then another integer, another character. So if you have char a, you have to tell me at which location I can insert it. Yes, character a will occupy which location?
0.
0.
Yes, it will occupy 0th location. Then you have an integer. Where should I start from?
4.
4.
4.
Very good.
4, 5,
Very
6,
good. You
7.
can start. Yes, 4, 5, 6, 7 will occupy integer I. Okay, then you have another character. Where can I use it?
8.
8.
Yes, and next character at 9. Okay,
9.
so you have to read 4 locations, that is 4 bytes. Then you have to read again 4 bytes for integer, and again 4 bytes, which will include your character B and character C. So total, it is by padding, it is 12 bytes. But if you use packing, character A 1 byte, just a minute. Character A will occupy 1 byte. Then consecutively you can store the next by packing, that is 4 bytes for integer, then again 1 byte, and then again 1 byte. That means 1 plus 4, 5 plus 1, 6 plus 1, 7. So the size of the structure by packing is 7, but the size of the structure by padding is 12. That means, as you can see, you have saved the number of locations, right? So such questions can be asked in the interview, okay? Whenever you go for your placement drive. That means, though this concept, okay, it is actually a theoretical concept, okay, means how you can optimize your program. It is not dealing with any programming feature as such. It is like how you can optimize your program. Such question can be asked, okay. With the modern processors, you don't have much effect by padding and packing, but you can, it happens that such questions are asked, okay. It is an important feature. Now you might be wondering that my OS is 64-bit, right? I'm using 64-bit Windows, but I'm the same thing I'm doing, and I'm getting it as per the 32-bit, right? As per the 32-bit, 4 locations I was using, and I got it. That is because my compiler is 32-bit. Okay, it depends on your compiler as well. As you can see here at the small thing, TDM GCC 4.9.2, 4.9.2, 32-bit release. Okay, it is a 32-bit compiler. Okay, that means your 32-bit compiler can work on 64-bit OS, and it will read or compile at a time 4 locations. Similarly, if you have 16-bit compiler, it can work on 64-bit OS. But if you have a 120-bit, 128-bit compiler, it may give problem. Okay, so this is how I can use the 32-bit compiler on my 64-bit OS. Okay, have you understood padding and packing?
Yes.
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 Yes, and now related to the same thing, that is memory management and how you can save your memory or how you can uh, do some operations related to your memory. Another user-defined data type is union, okay, which we'll be seeing in the next session. Union is also used to deal with the memory operations basically. Structure and union is same, but union has certain additional features. Okay, so if you have any doubt, you can ask me. Otherwise, put your attendance in the chat box. Any doubts?
No.
Okay. And I have also uploaded the quiz on arrays and the assignment on arrays. Okay, there are only 4 questions in that assignment and 8 questions in the quiz. It is a 30-minute quiz, like the quiz on pointers. You'll get this time 30 minutes for 8 questions, and you have to solve it. Okay, attempt it as soon as possible. And okay, I want to show you one more thing. Just it will take 2 minutes. Last time when we were passing the arrays, structure of array to our different functions, okay, that time it was returning some weird values, right? So the answer to this, the reason for this is, as I mentioned, that your uh, structure variable is acting as a pointer to the actual variables in the structure. So if you're using pointers concept, you will pass the address of the structure of array. That means, see here for this program, I'm calling this function and I'm passing the structure. The structure name is struct student data. I'm passing this array of structure to the function. Means I'm passing the address. And if you're doing anything on your address in your function, in this accept function, I'll work on that address. So whatever changes happen will be done throughout your program, right? Because you're dealing with the actual memory address. Okay, that is why you don't have to return anything. Whatever will be done will be for all the functions, right? Have you understood this?
Yes.
Yeah. So I want to show you one program and then we'll wind up. See here, this is a structure for student mark sheet actually. You have the roll number, name, and his marks. Then you have an accept procedure to accept the details of the student. You have a display procedure to display his details, and then you'll sort the details depending on how much he has scored. So you can display the rank of the student who has stood first, stood second, and so on. So you'll accept it by calling this accept procedure. Okay, enter the details for record one and so on. You'll enter. Okay, then for you'll display them. Okay, and then you will sort them like in descending order, means the one who has scored highest marks will come first, then the one who has scored lowest marks will be at the last. Okay, you'll sort them based on the marks part of the structure. Okay, we have seen how to sort it. And then after sorting you will display with the rank. So let me run this program. How many records you want to enter? Suppose 3 students, roll number 12, his name, suppose this one, is marks. So let me enter the minimum marks first. So this, if this is 12 is the minimum, after sorting it will be at the last rank. Then roll number 45, his name, and roll. Suppose he has scored 98, and another roll number 56. Or let me take roll number 1. His name is something, and his marks. Suppose he has scored 67 marks. So before sorting, I have displayed the record, and after sorting, I've got 98 marks first, then 67 marks student, and then the 12 marks student. And as per that, I've entered the rank. How I can know the rank? Simply, it is in the sorted order. Just keep on printing 1, 2, 3, 4, 5, 6. Okay, that is how you got this rank. So go through this program which I'll send you, and you can modify it on your own. Have you understood?
Yes.
Okay.
Yes.
So if no more doubts, you can leave this meeting. Thank you.
Yes, in the last lecture also, in the same program, we were trying to take only one alphabet like car, and it was not able, we were not able to take that alphabet.
Yes.
So test that with the phone number thing.
Yeah.
So what was the reason behind not
Yeah,
working? Okay.
actually, it is not accepting. Don't know why. I think I'll have to. Means sometimes when you write your scanf, you must write it at a specific position in your program, or maybe you have to declare your variables above all the scanf, something like that. Okay. So you can try it also. Even I will try, and I'll let you know.
Okay.
Yeah.
Thank you.
Welcome.
Thank you.
Welcome.
Thank
Thank you.
Welcome. Welcome. Welcome.